Hello, welcome to Introductions to System of Equations. In part 1, we're going to look at identifying solutions to a system of equations. Before we get started, we need to understand what a solution is. A solution here is the place where two equations intersect. A point where two equations intersect. Okay, so we're looking for an ordered pair. So a point where two equations intersect, and that point is going to be x comma y most of the time. Now we can have an equation and we can have no solution. We'll look at those cases, but for now let's focus on the solution being a point where two equations intersect. So I have two equations and now I have an ordered pairs. So it says for each ordered pair determine whether it's a solution to the system of equations. Well, for this to work, each point has to make both equations true. So we're going to plug and chug here. And by that, I mean I'm going to take each ordered pair and plug them in to each equation. So I'm going to take -6, -5 and put it into both of these equations. And they have to both be true for it to be a solution. Both statements would have to be true. So I'll show you what I mean by both statements. So we're going to label these point 1, point 2, point 3, and point 4 so that we understand where we're working so we don't get confused. So for point 1, I'm going to take -6, -5, and I'm going to put it into equation 1. So I'm going to put it into y equals first. So I'm going to have -5 equals 9 times -6 plus 4. So I want to make sure that all of this math gives me -5. So does -5 equal -54 plus 4? That's not going to equal, so this is a no. Now if one's a no, they both have to be true. So the point has to work in both equations, so since it doesn't work already, we can just say no. So let's go to 2. The point has to work in both equations. That's an important thing to write down. Let's look at number 2. I'm going to look at the point 0, 4, and I'm going to plug it in up here. So we're going to start with 4 equals 9 times 0 plus 4. Well, that equals 4 equals 0 plus 4, which does in fact make it true. 4 does equal 4. Okay, so this one checks out. So let's go check the other equation. 3x, so 3 times 0 minus 2 times 4 equals -8. 3 times 0 is 0, minus 8 equals -8. 0 minus 8 is -8, equals -8. So both points work. So it is a solution. So if I graphed this, my lines would cross at 0, 4. Let's look at 1, 13. I'm going to put 13 in up at the top equation. So 13 equals 9 times 1. Plus 4. Thirteen equals 9 plus 4, which is 13. So 13 does equal 13. So that one's good. So now we have to check the second one. 3 times 1 minus 2, 2 times 13 equals -8. Well, this is going to be 3 minus 26. That's not going to get us anywhere close to -8, so this is a big old no. So this one doesn't work. And let's check number 4 real fast. -7 equals 9 times 2 plus 4. So -7 equals 18 plus 4. This is also not going to work. I don't have a negative value over here, and this is -7, so this is also a nope. And I don't have to check the other equation because both statements have to be true to work. So that's another big old no. Alright, let's go look at another one real quick. Alright, in part A it says, for each ordered pair, determine whether it's a solution to the equation. So remember, we're going to plug and chug here, so we're going to take these values and plop them right up in here. And let's go ahead and label these 1, 2, 3, and 4 so we don't get them confused. So I have -4 and -2. It's going to go in for x and y. So let's look at number 1. So I have 6 times -4 plus 7 times -2 equals -5. This gives me -24 plus -14 equals -5. I need a little negative. 5 is a little negative, and this is going to give me a bigger negative. So this one's a big old no. Which means that whole point doesn't work. Alright, so let's check number 2. I'm going to do 7 times 6. I'm going to plug in 7 for x, so 7 times 6 plus 7 and 3 for y equals -5. Well, this gives me 42 plus 21 equals -5. There's no way. So that's another big no. And remember, both points have to work in, or the equation has to work in both points or it doesn't work. Alright, so far, no and no. Let's try -2, 1. Let's go to number 3. I'll use a different color again. So -2, so 6 times -2 plus 7 times 1 equals -5. Well, this gives me -12 plus 7 equals -5. So -12 plus 7 is -5 equals -5. And that works. Alright, let's try in the second equation. So we have 3 times -2 minus 2 times 1, and that equals -8. So now I have -6 minus 2 equals -8. -6 minus -2 is -8 equals -8, and that one works. Good. So that's a yes. Alright, let's go to number 4. Move that one down here. So number 4 is 5, -5. So we're going to plug 5 and -5 in. So it's going to be 6 times 5 plus 7 times -5 equals -5. Well, this is 30 plus -35, which equals -5. Well, 30 plus -35 does equal -5. Okay, so that one works. Alright, so let's see if that point works in the other equation. So I'm going to have 3 times 5 minus 2 times -5 equals -8. So I'm going to get 15 minus -10 equals -8. Well, this is going to be plus plus, and it's not even going to give me 8, so no. This is a no-go. So it's no solution. Alright, gang, so just plug and chug and work your way through it. Alright, good luck.